Oh, no, because, yeah, milliseconds because we had microfarads. Yeah, there we go. 3.18 milliseconds. So we have, that means 3.198 milliseconds. And how long does it take for the capacitor to fully charge? Five tau. So always remember that. So 5 tau is how long it takes the capacitor to fully charge. So now basically what we have at this point is we have enough information to solve. We want to know what is the voltage of the capacitor 1 after so much time. Now when we look at it, what we have here is we have 1.599 milliseconds, which if we look at compared to our tau, it's not even at 1 full tau yet. So remember on our chart when we're looking at it, this is the curve of where the capacitor charges to. This is 1 tau, 2 tau, 3 tau, 4 tau, 5 tau. So 1 tau, remember we are at 68% fully charged. So this time is 1.59 milliseconds versus the 3. That means time-wise we're going to put it about half, which means we'll probably see the voltage right in this range. So my guess is probably around 40% charge, just off the top of my head. Okay, how do we actually calculate that? Well, we have a formula for solving this. Voltage of the capacitor is equal to V final plus V initial minus V final times e to the negative t over tau. Okay, this one's just a straightforward question. It just wants to know, what is this voltage after so much time? Well, our time is right there. So plug in our values and we just solve it at this point. So the V final is the value or the voltage that the capacitor is trying to get to. And in this case, it's the maximum voltage that's available to it, which is the 26 volts. So we have 26 plus the initial voltage, remember, was 0, minus 26 times e to the negative 1.599 milli divided by our tau, which is 3.198 milli. Then we just plug this value into our calculator, and that will give us what the voltage of the capacitor is after so much time. And what value do we get when we run that into our calculator?
Got 10.230.
And that would be correct.
I was trying to go through and figure it out, but I did what, the V final minus the whole everything else?
Right. Yep, it needs to be plus.
Yeah, I'm like, I can't. I've got like 25 volts going in. I've got like, and it's saying that my VC is like 40, and I'm like, that's not right.
Right. So, and this matches, so remember my guess earlier about 40%? If we take this voltage divided by the 26, that was pretty close. Okay, so all these questions are going to be very, very similar. Okay, we're going to be doing is given a different capacitor, and it's going to, different capacitor, different resistance, different voltages, and then we're just given different times, and we have to solve for those. There will be some other times where maybe we want to know, okay, I want a capacitor to charge up, but I want to be able to design it for a value to where, let's say that it takes it 5 seconds to start up. Well, I have a capacitance value. What resistor do I need? Well, then we would go through this formula and solve for tau, and then solve for what tau needed to be, and then solve what the resistance and capacitance needed to be. Definitely something that we can always work through with these. It just depends on what information we're given and what answer I need and what value do I need out of every single one of those.
Questions on the quiz?
I do not believe so. I think they are all, yeah, I think they're all just about the voltage ones for this quiz. Yep, all of them look like they're voltage and tau, but like I said, we could do it if we wanted to, needed to. Okay, so that's the DC capacitors time constant quiz. The double points quiz, this one I believe is not required for the test, but it is required for part of your homework grade. So the difference between this one is you're given the same type of circuit. You're given a voltage, you're given a capacitance, you're given a resistance. The difference is it wants to know how much time does it take for a capacitor to charge up from one specific value to another specific value. So in that, what you have to do is you're going to solve it like normal. So I'm going to say, okay, what I need to solve for time when I get to 2 volts, and you'll get that value. And then you're going to go through and you're going to solve for time for when it hits 4 volts. And then you have your 2 time values, and you just subtract them from each other, and that will give you your overall time between those 2 points.
So are you saying you would solve it as normal and then subtract the values that we got from each other?
Yep, subtract the 2 times, because you just want to know when did this event occur, and then it's asking what's the difference between those 2 times. That's the double points quiz.
I'm having trouble understanding how to do that.
Okay, yeah, I can do one. So the circuit we're given looks like this. We have 31 volts across our supply. We've got 6.8 nanofarads and 3.3 kiloohms. And the question it asks is, find the time as the capacitor charges from 8 volts to 17 volts. And the answers it's looking for is tau and time. And the time in this case is going to be given to us in microseconds. So what we're looking for is we want to find the time that it goes between these 2 points. So what we have to do is we have to find how much time does it take to get to 8 volts and how much time does it take to get to 17 volts. The tau is the easy part. We take our 3300 multiplied by the 6.8 nano. Oops, times 10 to the 9th. How much did you say?
22.44 milliseconds.
Because remember the let's see. Why is my calculator in radians? Dang it. I punched something in there. I had something all screwed up. Yeah, 22.44 microseconds.
Right, it's nano, not micro. I see what I did. I see what.
Yep, because remember, nano is to the -9th. Okay, so what we need to do is let's find out the time that it takes for this capacitor to charge up to 8 volts. So remember our formula, VC is equal to V final plus V initial minus V final times e to the -t over tau. We're going to be solving for t. So we have 8 is equal to 31 plus 0 minus 31 times e to the -t over our tau, which was 22.44 micro. So to solve for t, we need to get everything away from it.
Pretty quick question. For the V initial and V final, couldn't you just plug in like the two numbers you're trying? So you could do like, for B, you could do V initial as 8 and V final as 17?
Let's try it. We'll try it both ways and see what they get up. I think there's something else that it doesn't get to, but it might work. We'll solve it both ways. I'm trying to remember there was something that we had done before. I just didn't include it in my notes if we could or not. So yeah, we'll solve it this way and then we'll solve it using those values. So we use this, we subtract 31 from both sides. So we're going to get a -23 is equal to a -31 times e to the -t over tau. And we know what tau is, but I'm just going to leave it in this form so it's easier to write. We divide both sides by -31. So we get 23 over 31 is equal to the e of -t over tau. And how do we get an exponent away from how do we get the exponent down to where we can manipulate it?
Log?
Yep, we use logs, okay? And since it's base e, we can use the natural log. So we take the natural log of both sides, and we end up with the natural log, which is log base e of 23 over 31 equals -t over tau. And then we multiply both sides by -tau. And we end up with t is equal to -tau times the natural log of 23 over 31. Now the reason I left 23 over 31 is because it gives us a decimal, and when we use the natural log, if we have more of that decimal in there, it will give us a more accurate value. So that's why I just left it in that format instead of converting it to the number. Then I let the calculator do it, and then I don't lose any data. So our tau, if we remember, was 22.44 micro. And so what we get is t is equal to that's not right because we can't have, yeah. I think I fat fingered something wrong in there.
6.698 microseconds.
That sounds better. I think my calculator's dying. That's why it's giving me weird random values. Okay. So this time is how long it takes it to get to 8 volts. So now what we need to do is we're going to do this whole process again, and we need to solve for when our voltage of the capacitor is equal to 17 volts. I'm going to go through and verify those values on the different calculators, how to find it first.
Answer of that.
Oh, this is the 17 one?
Yeah, just I added the 31 over, and that got to a negative 14. And then since all of the other conversions are already in place, it can just replace the 20, skip all the way down to the last thing, and just swap 14 into the 23.
Yep.
Plugging all that in, I got 17.838.
And what'd you say?
17.838.
Okay. So that's how long it takes it to get up to the 17 volt. Now we want to know the time that it takes to go from 8 to 17 volts. So now we subtract those times.
11.14.
And there's our answer. And I'm just verifying the numbers, running through them right now.
Okay, so then if what I thought was correct, we should get an 11.14 by plugging those two numbers, by plugging the 8 and the 17 into the original equation, I think.
Okay, we can try that. So the only problem is when we put in this final voltage, the final voltage isn't 17. The capacitor is trying to charge all the way up to the 31 degrees, or 31 volts.
Okay, I got it. So we can't, so it's not that.
Mm-hmm. That's the difference.
Yeah, okay.
Because this is based, so basically this part of the formula here is based on getting to the 31 volts and and the 68%, 93, all those things. It's based on getting to the total voltage. So we can't use that to solve in there because that doesn't take that into consideration.
Okay, yeah, that makes sense.
So that is how you do those.
Cool. Okay, I think I got a good enough understanding to be able to finish up all the rest of the quizzes now.
Okay.
What is the answer to this one again?
This one, the final answer comes out to be 11.14 microseconds.
Oh,
Of the overall answer, but of the answer for the 17 volts.
Okay, so that's what we do.
Yeah.
I thought we took 17 minus 6. The 6 value that we got.
Yeah, so this was at the 17 volts. So this is how much time it took to get to 17 volts. This is how much time it took to get to the 8 volts, and we want to know the difference from how long it took to go from here to there. And that's where this is.
Okay, that makes a lot more sense. Thank you.
Mm-hmm. And then the last quiz that we have that we haven't really talked about, again, it is not required to take the test, but like I said, it is part of the grade. It is the triple points problem, the DC mix and match. The trick to solving this one is, again, what is happening in the circuit. Because if you look at the equation, we're not given any time. So we're assuming that this circuit is on and everything is time has elapsed, and so everything that's going to charge is already charged to a max value. So the idea being is when a capacitor is charged to the max value it can get to, that means it is going to be treated as an open. So what we do is we need to remove the diode and then figure out in this circuit if those points give it a voltage to either turn the diode on or off, forward or reverse bias, and then determine what is going to be the voltage drop of that diode after we put it back in, and then we reevaluate based on that. So there's a lot of different steps, but I want you guys to kind of try that over the weekend, and if you don't quite get it, don't put too much thought or effort into it if it's going to cost you time on getting quizzes completed, because we will discuss this one again next week, and then you guys still have a chance that you can come back and complete the quiz before the end of the semester. But try it because it is good practice, and it uses everything that we've talked about this semester in this. And that way, that's one reason why I like this question, but it is not it is not a requirement to unlock the test for week 7. Does that make sense?
Yeah, makes sense. Just wanted to check this with you really quick because I think I just figured out a little bit of a shortcut for this last equation we just did.
Okay.
I found made a full equation that just simplifies it down, which was find the t. It's t equals the negative tau of the times natural log of the negative voltage, negative VC plus voltage final divided by voltage final.
Read that to me one more time.
Time equals negative tau times the natural log of negative VC plus VS divided by VS.
I believe that is correct.
Yeah, I mean, from what I'm seeing right now, it looks right. If I have problems, I'll just resort back to doing exactly this. But I'll definitely run some tests. I think I'm gonna at least try it because being able to save time is never a bad thing.
Right, and I believe that does come down to that value. The only difference is the value inside your natural log needs to be positive.
Yeah, that's the so you have like the negative VC.
Oh, gotcha. Yeah. So VF minus VC.
Yeah.
There you go.
Like negative 17 plus 31 would get you to the 14.
Yep. Yeah. So yeah, it's your V final minus your V capacitor.
Yeah, either or, I think.
Yep.
Yeah. Cool. Awesome.
All right, guys. So, yep, you're welcome. So we are pretty much out of time. Hopefully the guys has helped you guys. And like I said, I will get these 2 videos and get them posted on Moodle. I will just add them underneath as just kind of like review videos, things like that. That way they'll be there. It'll take it probably a couple of hours to get them posted on YouTube. So but the links and everything I'll have on there so you can keep trying back. It's going to take them some processing time to get them up and going. But I will get those started the second we're done here. If you guys do have any questions, as always, please feel free and reach out to me. Again, On Sunday, I won't be available a whole lot. We got a lot of stuff that we're doing, and we're going to be running around, and I won't have my phone right next to me all the time. So if you do have questions, you know, work through these quizzes today, tomorrow, and get what you can done, and we'll kind of go from there. Um, and remember, get those quizzes done. Good job or good luck on your test, which the test, remember, is going to cover the material from last week. So it's not going to deal with the capacitors. It's going to be dealing with last week, which was mesh. So make sure you guys review that, and that's what's going to be on the test.
Most of the tests this week is like mesh loop stuff?
Yes, the test will be on mesh.
Oh, okay, well that shouldn't be too difficult then.
Right.
All right, awesome. Thanks, Brody.
Okay, any final questions? Okay, my little robotic minions, go forth and terrorize the world with our great creations.
Thank you, Brody.
You're welcome.
Thanks.
Oh, also, did you appreciate the fancy cats for Fancy Friday?
Yes, I did. I did appreciate them.
It was all like,
I would have joined in if I knew how to change my profile picture.
oh, you just go to if you right click your Zoom icon on the bottom, you can open up Zoom and then click your little icon in the top right, and then click more settings. It'll take you to a web page, and then you just go to your account on there and you can change it. Also, the Rickrolling I've been trying to do since Tuesday, but things kept getting messed up, so we did it today.
Fair enough. I get it.
I didn't know there was a studio effects on this either.
Oh yeah, check it. Choose video filter.
But yes, what kind of mustache looks good on me, by the way?
I am now a pig. I mean, I was before, but you know.
That is a pretty good little mustache you got going on there. Mine would blend in.
There we go. That's a little bit better.
Yep. Let's see. Fancy Friday.
Beautiful.
Trying to remember who was.
Wow.
That's what I was going to say. So let's see. I'm trying to think who all we had on this call. Not. Yeah, no, I saw all the fancy cats and I'm like, that's hilarious.
It was Paul's idea.
Well, he changed his picture earlier. Because earlier when I was talking to Mary during lab, I got back in and what it was is because when I left the meeting because I couldn't go into a breakout room on my phone, so it made me make somebody else the host of the meeting, and I just picked the first name that popped up, and it was Saul. And so Saul basically changed his picture to he's like, I am the captain now, and was screwing around with everybody.
Yeah, we're doing a robotics boot camp right now, to try and get Mary and Saul to pass.
Sounds good.
It's basically just sitting in a Zoom call, and when they have questions, they're like, Bella, I have a question.
Speaking of which, are you going to do that again later today?
Yeah, we started at 11 today.
Oh, you're already and not sleeping. Well, okay.
Yeah, that's Saul. He's apparently on hour 38 at this point, probably, of not sleeping.
You should probably get some sleep before you take the test.
Yeah, those caffeine pills can only go so far, man.
I should probably take off the beard and eyebrows, huh?
We don't have a solution to sleep to